Oh my gosh. Right here, 11:28.
They just heard that video.
Okay, we have this thing called a postulate, and I feel like outside of math, no one ever says the word postulate, but they do say the word axiom. Have you ever heard of that? Maybe that's a math term too.
Have you watched Wall-E, that big ship that they're on in space? It's called the Axiom.
I don't know.
Yeah.
Dude,
How do you
that
know
is
that?
So
creepy.
most things in math, like theorems and stuff, have to be proven. A postulate or an axiom is something that we just accept without proof. I like to think of it as like, yes, it makes sense. We don't have to justify it. All right. So it is a statement that is accepted as true without proof. And today I'm going to give you your first postulates. The postulates are numbered. Theorems are numbered all throughout this book. I do not expect that you memorize these numbers, right? On a test, I do not expect you to say, postulate 2.7 states, right? I don't expect that you know the number. I expect that you're aware of what it's saying, right? Because there's a postulate that says blah, blah, blah. But the numbers are only numbered for this book. It's not known that that's postulate 2.1 by any other book but this book. Does that make sense what I'm saying? All of these things we discovered in chapter 1 about points, lines, and planes. We're just putting them in postulate form now. Okay, so I have some fill in the blanks for you. Hopefully you kind of know the answer to this.
How does this have anything to do with proofs?
Because we're going to prove why things are true using these. Okay? So, through any 2 points, there is, yes?
Sorry, but you said, okay, you said we're going to use proofs to prove this, but then the postulate is the statement of this.
We're going to prove things, but use these to justify what we're proving. So, like, in a minute, there's going to be a problem, and it's not really a proof yet, but it's going to say, how do you know that this is a line? And you're going to say, because there's 2 points on it. And postulate 2.1 says through any 2 points, there is exactly one line. Does that make sense what I'm saying? Like, we're going to prove other things and say the reason it's true is because of this accepted thing.
Why do they call them 2.1, 2.2?
You know how to answer that question? Why do they call them 2.1, 2.2? It's because it's chapter 2, and it's our first one. So they call this 2.1 because it's chapter 2, and it's our first postulate. In chapter 3, they'll start over, and they'll call them 3.1 and 3.2. But the numbers really mean nothing. Outside of this book, they mean nothing. If you look up answers in the book, they'll say postulate 2.6 says whatever. On a test or a quiz, when you don't have these in front of you, I don't expect that you know the numbers. But I do expect that you know that through any 2 points, 2 points make a line, right?
We'll be like mathematicians when we're like 50 years old or whatever, and we'll catch ourselves saying, postulate 2 point, and it'll go, what? What are you talking about? Like, that is great to know when you find out.
I highly doubt you do also.
Unless we're talking about how we're never going to say it. Like, remember when we said we never say that word postulate?
Right, I say the word postulate a lot, but I don't put the numbers with it. Like, there's something called the segment addition postulate, and I always bring it up in other classes, and no one else remembers it but me. But I say that. It's named, but the number doesn't mean anything. But it is important that you know if you have 3 points that are non-collinear, that's what makes up a plane. So 3 points that are non-collinear, then you can say there's exactly one plane that goes through that. And there's just examples here. These aren't so nice on your copy because the copier is crappy. But this is in your book. Exactly. This chart is in your book. You should look at it sometime. A line contains at least, I feel like that's the same as 2.1. Do you think it's going to say 2 points or 3 points?
I think it's going to say 2 points.
Well, it has 3 points on there.
It's going to say 2 points.
Gotcha.
Don't you see how this one and this one, like, almost say the same thing? If you have 2 points, then you know there's one line that goes through it. If you have a line, you know there's at least 2 points on it.
Right.
So going along those same lines, what do you think this one's going to say? A plane contains at least
1 plane, 5 points.
3 points.
through any 3 non-linear points, there's exactly one plane. So a plane must contain at least 3 non-collinear points. So 3 points if they're not all on the same line. Right? Tiny units.
I did write it number 3.
Oh, I know. So 2.5 says if 2 points lie in a plane, then the entire line containing those 2 points also lies in that same plane. So remember that a plane, it looks like a rectangle on a piece of paper, but the sides of that just keep going forever. The line keeps going forever. So if 2 points are on a plane, then that line is also going to be in that same plane. You should know that stuff from chapter 1, but if not, you should probably look over those. Also, other postulates that we accept as true that hopefully make sense to you. If 2 lines intersect, what do they intersect in? If 2 lines intersect, then their intersection is exactly 1 point. Oh my gosh, look, it's written in the if-then format. That's how we write things in math class. You might just unstaple it if you're going to put it in a binder, might be the best. And yes, you could argue that if there was the same line, then they would intersect in more than 1 point, or if they were parallel, then they wouldn't. But if 2 lines intersect, they're going to intersect in 1 point. If 2 planes intersect, do you know how they intersect? Maybe the picture can help you.
With the line in between.
Yeah, they intersect in a line. So if 2 planes intersect, like think about if I took 2 pieces of paper and I cut a little slit in both of them. When they intersect, they're going to form a line, not a point. And we also talked about that in chapter 1. What?
When they explode,
Okay, when they explode.
if 2 planes intersect.
Different kind of plane there, honey.
I feel like that's something that you could say to your son or something. That's something I feel like, I don't know.
Okay, so your homework today is not really proving things, but it's learning to justify your answer based on the postulates. And we can actually write the postulate number if you want, but I think you should more focus on what it's saying, all right? So, look at the next example. How blurry is that picture that's on your paper? Really blurry? Can you see all
Not
that
really.
stuff?
No,
You can
I
kind of
mean,
see it.
it's not as clear as that.
And so it says, explain how the picture illustrates that the statement is true, then state the postulate that can be used to show that the statement is true. So A says, points F and G lie in plane Q and on line M. Line M lies entirely in plane Q. Goodness, there's a lot of stuff in that.
What are we
So, how could we say, right, looking at this picture, here's a Q. Can you see the Q on your paper?
Yep.
Points F and G lie in plane Q. Like these are true statements. They're not trying to trick you. And on line M. So let's do the line part first. Forget about the plane. What postulate would go along with the fact that points F and G are on line M? Yeah, that's true because 2 points make up a line, right? And then it says they lie in plane Q, and line M also lies in plane Q. Do we have a postulate that talks about if 2 points are in the same plane, then the line containing them is also in the same plane? I think that was one of the last ones, yeah. It says exactly what I just said, right? I copy and pasted the book answer on this, not that you have to write this much, but just because I wanted you to kind of see what they wrote, and then we're going to kind of make up our own answer, okay? So let's see if I can find this. Oh, look at this giant answer, right? Points F and G lie on line M, and the line lies in plane Q. Postulate 2.5, we said that, right? States that if 2 points lie in a plane, then the entire line containing the points lies in that plane. Shows that this is true.
Can you start the postulate 2.5 shows it's true?
You can, but no on a test, you're not going to remember that that's postulate 2.5, right? Like, I think it's a better answer to say 2 points lie in a plane, then the entire line containing the points lies in the plane, shows that that's true, right? That would kind of be what you would say, but if you want to write postulate 2.5 and you just go back and look at it, right, that's an okay answer. But that's what they're talking about. Like, why is it true based on the postulates that I gave you? I think B is less complicated here. C determine a line? It says 2 points make a line, or any 2 points form a line, right? It doesn't have to be word for word, but I would say this is true because 2 points make a line. I don't know the postulate, the number, I just showed you, but I don't know it because I don't care about the number. But if you want to do the number, I'm okay with that. So since you have the notes right in front of you, I'm going to show you the book answer. Oh my goodness gracious.
Balls pie.
2.1, that's what Mackenzie said though. Postulate 2.1 that says through any 2 points there's exactly one line shows this is true. They just write like, they're just ridiculous. They just say like, because it lines on the edge. I would say because 2 points make a line. Or through any 2 points forms one line or something, right? Like you don't have to write a big paragraph. I just think it's sometimes worthwhile to see what they write so you can kind of see what we're looking for. When we prove things, all right, when we prove that something's true, we have to say something and then we have to give a reason behind it. That reason could be like because the pattern shows, like inductive reasoning. But most of the time in math class, that reason is because of a rule, a postulate, or a theorem that I'm going to give you. And so you have to say something and then you have to justify why it's true. And so that's kind of what we've been building up to this whole year. Tomorrow we'll prove things. And then next week we'll probably spend the whole week proving things. So, okay, I think this next one's like a check for understanding, but it's multiple choice. So we're going to do like a signal for it, okay? So don't yell the answer out. So it's the same picture. It's not on your paper. And it says point P contains points E, B, and G. And then which one of those statements justifies that that's true? So we're just going to do like numbers, I think, for this one. So like A, you're going to hold up 1 finger, and B, you'll hold up 2 fingers, and 3 fingers, and 4 fingers. Let's make sure the 1 finger you hold up is the first finger, right? Don't hold up an inappropriate finger.
That's funny.
Holding up.
I never even thought about that.
Just making sure. What did I say?
It looks right at it.
Oh, well.
Right finger.
Can you blame her? Yeah.
Who else would do that?
No. Okay, how about first? We'll do that.
All right, what do you think? Hold your fingers up. Aaron, just looking at me. Plane contains 3 points, right? That's what it's saying. Plane P contains points E, B, and G. E, B, and G. What plane is it? Oh, plane P? Oh, that's weird. That kind of doesn't even look like B's on there, does it? We're going with it, though. Whatever. It seems like it's on this plane, though, right? But it could also be, could it be on 2 planes at once? I don't know. That's weird. We're just pretending it's true, okay?
Whether you like it or not.
3 non-collinear points make up a plane, so I think C is supposed to be the right answer. Oh, another one. Same rules. 1, 2, 3, 4. Okay, for A, B, C, D. Line AB and line BC intersect at point B. Oh my gosh, we had a postulate about this. Line AB and BC, yeah. Same answer as the last one? C. See your way out, right? If 2 lines intersect, then their intersection is a point. Right? That's not so bad. Is that all I have on here?
Yeah. Yes.
This is crazy. What? Wait, do I have this on your paper?
No.
Yeah.
Oh, we didn't have the last
Oh wait, no you don't.
Eric.
No.
I was like, I think there's more to this.
Never mind.
All right.
No.
Determine whether the following statement is always, sometimes, or never true. Explain. Probably we're going to try to explain using a postulate, I would guess. If plane T contains EF and EF contains point G, then plane T contains point G. True? Again, it says true. Why is it true?
If plane T contains EF, EF contains G, so that means that if plane EF
That's a whole long answer.
It's just true.
Stop.
It's just true.
What postulate would you say this goes with? Let's talk about that first. Do we have a postulate about a line on a plane? Snakes on a plane?
2.7.
Hey,
I am
that's
sick of
Snakes.
snakes.
There's
Plane.
freaking wrong.
that's like flashback. Yeah, Mr. Brian's.
What about 2.5? 2.5 says if 2 points lie in a plane, then the entire line containing those points lies in that plane.
Yeah.
So
Throwback Tuesday.
if EF is on plane T, do you agree that every point on EF is also on plane T? Based on postulate 2.5? So I would say this is always true.
Where'd you get your answer that?
Because, and again, since you have your notes in front of you, if you want to say because postulate 2.5, you can.
Right.
But I'm going to say because all points.
If I did that, I would know nonsense.
Chandler and Allie.
I never did anything.
Who was talking with you?
Eric.
Eric!
I'm sorry. What?
Normally Allie and Chandler. So I wasn't looking and I was just always, because all points on EF will be in plane
That one was like straight over
C.
your head.
Yeah, I know. Oh look, oh we should do this.
Oh, I'm stuck. Wait a minute.
What the heck?
Oh my god.
What are you doing?
Just moving this room in. Oh my god.
Living young
Oh my god.
and wild and free.
So this is my answer. Always, because all points on EF will be in plane T. And they said always because postulate 2.5. They just wrote it wordier than I did.
Did you hear a joke? Yeah.
Always because sometimes always or never.
No.
Is that what you were saying?
We
No.
did.
Yes, because you're like always because it was sometimes. I'm with you.
Okay.
Chandler, here. Some people need quiet to learn. Maybe you don't need quiet to learn, but some people need quiet to learn.
I'm learning
You
words.
should see them in careers.
It doesn't. I don't
Yeah,
care.
and
It doesn't make it better in here. You have to stop.
She targets me too. Hey, same here.
Oh, if Gibby does something.
GH contains 3 non-collinear points. Sydney says never.
Oh, I don't know. I didn't actually read it.
Line GH contains 3 non-collinear points.
Sometimes.
How?
Because they could be on the same one.
I know.
You're giving me a look.
They could be on the same plane. Can you draw a line that has
Just
3?
kidding. Effort.
Right? Because it's a line. Like I think it has to be never because of point. I don't even know what
Three
possible
points
to go
can be on
to.
the same line if they're non-collinear. It's a contradiction.
Non-collinear points do not lie on the same line by definition.
That's gonna totally.
That's not really a postulate, right?
What are you talking about?
So never a line is collinear points, right? It's not even a postulate. By definition. That's another reason you can say something. Definition of non-collinear. Right? What's the definition of non-collinear? Points that don't lie on the same line? So by definition? Oh man, that was crazy.
Wait, we only have to do. Oh wait. You only have to do 3.
And on one page and then another one.
That's a whole bunch though.
It's okay. Alright, don't yell it out. Sometimes, always, or never, that plane A and plane B intersect in exactly 1 point. Always 1, sometimes 2, never 3. How is this the answer every time today?
See, it's always just if you don't know it, just see.
Because, why is it never?
Because
Eric?
planes cannot intersect
on the line.
Instead of-
Planes intersect in a line. Alright, so I cut this section in half so that we could focus on the postulates today and tomorrow focus on the proofs, okay? So your homework is 2 different pages, alright? On page 124, that's the necessary sufficient stuff. We'll see how that goes. And then on page 129, a lot of it is why is it true? There's a lovely picture of a cake that you can talk about are these on the same plane or on the same line. Then you get to say sometimes, always, or never. And that's it. Oh wait, just kidding. And then there's another picture. It's not that many, but sometimes, always, or never. I like those. You can say the postulate numbers if you want, or you can just write out why it's true based on why it's true. Alright, you do have like 10 minutes that you can start on